The end of physics is not a formula, not a theorem, but four monsters. This is not a joke. These four mythical beasts once drove the most intelligent human brain crazy. Maxwell was tortured by the first one for a lifetime. Schrödinger was suspected by the second one. Einstein has never been able to tame the third one. And the fourth one, no human has been able to answer his question so far. They are not mythical legends. They are experiments created by physicists with despair and madness. Maxwell's waste, Schrödinger's cat, Laplace's beast. These four mythical beasts point to the four loopholes at the bottom of the universe. The second law of thermodynamics may be false. The cat in the quantum world can live and die at the same time. The future of the universe may have been written long ago, and you can never catch up with a turtle. What's worse, these problems are not a joke by scientists, but the deepest cracks in the physics. Building. More than 100 years have passed. Not a single one has been completely killed. They are still laughing at the wisdom of mankind. Now, let me take you into the labyrinth of these four mythical beasts. Let's start with the oldest one. The first mythical beast, Maxwell's waste. In 1867, British physicist Maxwell wrote a letter. This letter threw a bomb directly into the physics world. He described a terrible scene in the letter. Imagine a sealed box full of air molecules. Use a board to divide the box into two halves. A small door is opened on the board. There is an invisible little elf standing at the door. This elf has a special ability. It can see the speed of each molecule. Fast molecules fly over. It opens the door and swings to the right. Slow molecules fly over. It closes the door. It stays on the left. Do you know what this means? The faster the molecule, the higher the temperature. After the division of this little elf, the right side is full of fast molecules. It gets hotter and hotter. The left side is full of slow molecules. It gets colder and colder. A box with the same temperature as the original was divided by this little elf into two halves. This directly violates the second law of thermodynamics. The heat cannot self-release from a cold place to a hot place. This is the law of the universe. But Maxwell's waste did it. What's more terrible is that if this little elf really exists, the mobile phone is no longer a dream. You can use the temperature difference between the left and right to generate electricity. It never stops. The fate of the whole universe will be changed. Because according to the second law of thermodynamics, the universe is heading for a hot season. All energy will become even heat. The temperature is the same everywhere. There will be no change. It's a dead end. But if Maxwell's waste exists, the universe can come back to life. This little elf has driven physicists crazy for more than 100 years. Until 1961, a physicist named Randall stood up. He said, "You all ignored one thing. If this little elf wants to separate molecules, it must get information. It needs to know whether each molecule is fast or slow. And to get information, it has to pay a price." In 1982, another physicist, Bennett, made a cut. The little elf's memory is limited. He separated so many molecules. There are so many information in his brain. It will be full sooner or later. What if it's full? You have to wipe out the old information to record the new information. And the action of wiping out the information will inevitably generate heat and increase injury. In other words, the little elf secretly reduced the injury in the box, but the injury on its own increased. The total injury of the whole system did not decrease. The second law of thermodynamics is still solid. In 2012, European scientists finally verified this with experiments. Wiping out a bit of information requires at least the energy of KTLN2. Although this number is extremely small, it proves a shocking fact. Information is not a vague concept. Information has quality, energy, and physical price. The little elf did not violate the law of physics. It just hid the price in the information. Although this little elf failed to break the second law of thermodynamics, it unexpectedly gave birth to a new subject, information thermodynamics. In 2024, Chinese scientists even made a real quantum board with a quantum chip to study the relationship between quantum entanglement and thermodynamics. 150 years have passed. This little elf is still active at the forefront of physics. The second mythical beast, the cat of Schrödinger. In 1935, Austrian physicist Schrödinger did a thought experiment. This experiment still makes physicists all over the world headache. Imagine a cat locked in a sealed box. There is a radioactive atom in the box. The probability of the atom changing is 50%. If it changes, a device will be triggered. If the poison bottle is broken, the cat will die. If it doesn't change, the cat will be alive. The question is, before you open the box, is the cat dead or alive? Ordinary people will say, of course, either dead or alive. We just don't know. But quantum mechanics tells you, no, before the moment you open the box, the cat is either dead or alive. It's not either dead or alive. It's either dead or alive. Only when you open the box and observe it, the state of adhesion will become a certain state. The cat will become dead or alive. It sounds like a crazy story, doesn't it? Schrödinger thought so too. He proposed this experiment to make fun of Leibniz's Gebenhagen theory. He wanted to say, look at how ridiculous your theory is. How can a cat be dead or alive? Einstein also stood on Schrödinger's side. He said a famous saying, when we don't observe the moon, doesn't the moon exist? But the strange thing is, the prophecy of quantum mechanics is verified again and again. Electrons can indeed pass through two crevices at the same time. Light can indeed go both ways at the same time. Adhesion is not an illusion, but a real existence. The question is, can the strange nature of the micro world extend to the macro world? Can a real cat be in an adhesion state? There is no answer to this question so far, but scientists have been trying to make the cat bigger and bigger. In 2024, a team from the Chinese Academy of Science and Technology created a record. They captured about 10,000 atoms so that these atoms are in two opposite quantum states at the same time. And this adhesion state lasted for a total of 23 minutes. And the former experimental adhesion state can only last for a few seconds at most. This shows that the time that quantum adhesion can exist is much longer than we imagine. In 2025, scientists from Austria and Spain found that the production of quantum adhesion does not necessarily need to cool the CLO system to the absolute 0 degree. In a relatively hot environment, it can also observe the adhesion state. What does this mean? This means that the boundary between the quantum world and the classic world we are familiar with may be more blurred than we thought. IBM researchers even used 120 quantum bits to create the fattest Schrödinger cat. This cat is used as a performance benchmark. Schrödinger originally used this cat to mock quantum mechanics. As a result, 90 years later, this cat became the core tool of quantum computing. History is full of sarcasm. The third mythical beast is the Laplace beast. This mythical beast is the most desperate inference in human history. In 1814, French mathematician Laplace came up with an idea. If there is an unknown intelligent being in the universe, he has the position and speed. Then, as long as these data are brought into Newton's motion equation, he can calculate the past and future of the universe, the trajectory of each planet, the motion of each atom, including what you eat today, what you say tomorrow, when you were born, when you died. It's all predestined 13.8 billion years ago, when the universe was born. This is the Laplace beast. It doesn't need to predict the future, because the future is the inevitable result now. It doesn't need to change anything, because everything has been written. You think you have free will. You think you can decide your own fate. In front of the Laplace beast, these are all illusions. Every choice you make, every thought you have, is just the inevitable result of the atomic movement. You are not making a choice. You are just playing a script that has been written a long time ago. This idea forced many people at the time to the brink of collapse. If everything is destined, what's the point of life? If there is no free will, where does morality and responsibility come from? The Laplace beast is not a mythical beast. It's a devil. But humans didn't give up. In 1926, Heisenberg proposed the uncertainty principle. It proves that it is impossible to accurately measure the position and momentum of an atom at the same time. The more accurate the measurement position is, the more vague the momentum is. The more accurate the measurement momentum is, the more vague the position is. This is not a matter of not being advanced enough. This is the rule of the universe itself. The Laplace beast wants to know the position and speed of each atom. Sorry, the law of physics doesn't allow it. Then, the theory of quantum mechanics took another step. Even if you know the initial condition, as long as there is a slight error, the final result will be completely different. The butterfly effect is the best example. A butterfly moves its wings and may cause another storm on the Earth, and at the quantum level, error is inevitable. The Laplace beast is dead. It has only lived for about 100 years. It is the shortest of the four mythical beasts, but the debate on the definition and the free will has not stopped so far. Quantum mechanics tells us that the universe is random. But is this randomness really random, or does it hide the law that we don't know? This question is still unanswered. The fourth mythical beast, the tortoise of Genoa, is the oldest of the four mythical beasts. It was born in ancient Greece 2,500 years ago. The philosopher Genoa raised a question that looked like a change. The fastest warrior in ancient Greece, Achilles, raced with a tortoise. The tortoise climbed 100 meters first. Achilles then set off to catch up. The speed of Achilles is 10 times that of the tortoise. It is easy to catch up with the tortoise, according to common sense. But Genoa said no, it will never catch up. Why? When Achilles ran 100 meters to the starting point of the tortoise climbed another 10 meters. When Achilles ran 10 meters, the tortoise climbed another 1 meter. When Achilles ran 1 meter, the tortoise climbed another 0.1 meter. This process can go on indefinitely. The tortoise can always create a new distance. No matter how small this distance is, as long as it exists, Achilles can't catch up. It sounds like a challenge, but what Genoa really wants to ask is a profound question. Can time and space be infinitely separated? If so, there will be an infinite number of time segments, and the infinite number of time segments should add up to an infinite amount of time. Achilles can't catch up with the tortoise, but in reality, Achilles can easily surpass the tortoise. What's the problem? This paradox has troubled humans for more than 2,000 years. Until modern mathematics developed, people realized that adding an infinite number of positive numbers may not be equal to an infinite number of negative numbers. It may also be a finite value. This is the concept of infinite number of positive numbers. The paradox was solved from mathematics, but physics gave a deeper answer. Quantum mechanics tells us that there is a smallest unit of time, called Planck's time, which is about 10 to the power of 43 times per second. There is also a smallest unit of space, called Planck's length, which is about 10 to the power of 35 times per second. There is no physical meaning than this smaller time and space. In other words, time and space can't be infinitely separated. The tortoise can't create an infinite number of starting points. When the pursuit process enters the Planck scale, Achilles surpassed the tortoise in an instant. The tortoise of Genoa forced humans to think about the nature of time and space with a seemingly boring change. After 2,500 years, we barely gave an answer. But this answer raised a new question. What do Planck's time and Planck's length mean? Is time and space continuous or separate? Is the universe we live in like a computer screen, composed of countless pixels with 4 animals and 4 questions? Maxwell asked, what is the relationship between information and energy? Schrödinger's cat asked, how to observe, decide reality. Laplace asked, is there a free will in the universe? The tortoise of Genoa asked, what is the nature of time and space? More than 100 years have passed. Laplace was killed by quantum mechanics. Maxwell was subdued by information theory. The tortoise of Genoa was trapped by Planck's scale. Only Schrödinger's cat is still alive, dead and alive, laughing at every human who tries to understand it. But the meaning of these mythical beasts is never to be killed. Their meaning is every attempt to subdue them pushes human cognition to a new boundary. Maxwell was subdued by information theory. Schrödinger's cat promoted quantum mechanics. Laplace's beast triggered the theory of chaos. The tortoise of Genoa inspired quantum mechanics in space and time.